Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1, to present about lift design for hotel. Me and my team, Aizat Amshari, Muhammad Amri, Muhammad Najibuddin, myself, Muhammad Zafri, and Nur Ali Ashazwani. We present about the lift design for the hotel that we have choose for our project.
Okay, my name is Muhammad Amri, and I will explain about the introduction. Okay, lift are machine which are required care and scheduled maintenance to ensure that they can function properly. If maintenance is not conducted properly, breakdowns will occur, which lead to higher costs and downtime. Owners are encouraged to educate users on the safe operation of lift to avoid accidents. So the benefit of using lift are felt not only by those working on living in high-rise buildings, but also by those living in low-cost buildings. Okay, for the research background, the level of care certification is the criteria by which the efficiency of an elevator system in a building is measured. The efficiency of the elevator may be determined by the peak demand at the allowed time, the time it takes to go up and down, and the capacity of the car. The second one, the existing structure was designed with a two elevator system that feature a emergency elevator. There are numerous floors in the hotel that contain 5 to 10 rooms at a time at each level. Toilet, hotel rooms, a gym, laundry, and co-play area and meeting room are all incorporated in the conventional service building construction. The next research background is Can Delicious Sendirian Berhad built this project for Mega A Holding, Sendirian Berhad Company, and Can Delicious Sendirian Berhad with a price range of RM7,935 to RM10,180 per square meter, according to the Cost Construction Handbook 2020. Ground level, rooftop level, water tank level, and roof plan level are all included in its 16 floor design on Jalan Raja Chulan, Kuala Lumpur, Section 57. This project took place.
Next.
And then for the problem statement, the vertical transportation problem can be summarized as the requirement to transport a specified number of passengers from their origin floor to their respective destination floor with the least amount of passenger waiting and travel time. Lift cost, space, and energy. The key to solving any technical problem is to able to articulate it precisely. This lift trust-free engineering objective is to strike a balance between cost and performance. Numerous criteria must be optimized, including average passenger waiting time, every passenger journey time, and lift energy use. In effect, the vertical transportation issue is a multi-objective, multiple constraint problem that seek to find a solution such that is firstly safe and then functionally and reliable and cost-effective, able to meet the passenger performance requirement, which is waiting time and traveling time, and then able to use the smallest possible core space of the building, and then energy efficiency. For the design objective, to achieve these aims, the project cover the following objective. First, to identify the suitable design lift for hotel building, and then to make sure that lift that place is convenient to guests. Okay, for the design scope, when addressing the term design in relation to lift system, it is critical to differentiate between two distinct aspects of lift design, engineering design, and traffic design. Engineering design The purpose of the research is to examine the traffic design of lift system, not the engineering design. However, in other instance, it is vital to address specific engineering design subjects since they are inextricable tied to traffic design and have substantially influence on the decision made throughout the traffic design process. And then consider the influence of shelf space on the selection of the lift rate speed, where the selection of the lift rate speed needs minimal clearance in the shaft pit and head, refer to as pit depth and headroom respectively.
Assalamualaikum, my name is Muhammad Zafri Muhammad Rizwan. Okay, next, I will present for the literature review for this project. Okay, so in this literature review, it consists 2.1 project information, 2.2 lift design guideline, 2.3 local document, and 2.4 international document. Okay, next slide. Okay, for the literature review, okay, uh, it is expensive and inefficient to have too many elevators, and when there aren't enough, the customers are left disappointed. Okay, to design practical spaces, architect must first understand how people move around in the building. A elevator may use up to 40% of the ground floor area in a large structure. The future research will continue to focus on developing more energy efficient elevators as well as stronger construction materials and more effective dispatching system. The research on elevators that don't utilize engine or even T is ongoing. So solar elevators, for example, use rooftop solar panel to generate both the power needed to run the elevator and surplus power that can be sent back into the grid. The next slide. Okay, for 2.1 project information, a building elevator system performer may be gauged by the level of satisfaction by its user expressed after taking a trip. According to the peak demand at the specific time, the time it takes to travel up and down as well as the capacity of the elevator may be used to determine how efficient the system is. The goal of this research is to improve the elevator system architecture of an existing office building that will be converted to a hotel. A major emphasis of this project research is the service apartment buildings elevator system. Okay, toilets, hotel room, gym, laundry, a coffee area, and a conference room are all included. Okay, next slide. Okay, 2.2 is lift design guideline. Okay, a passenger elevator was built at a New York City building in 1857, and Elisa Grace Otis was one of the first to develop an elevator, with more than 100 elevators going up in commercial and hotel buildings all throughout the country in 1873. This new technology was revolutionizing the transportation industry. The elevator in high-rise buildings make it simpler for residents to get goods up to their apartments. The passenger lifts, firefighting lifts, cargo lifts, and service lifts are among the most common. Traction elevators are most often seen in the high-rise commercial and residential buildings with at least 9 stories. The hoist table of gearless traction elevators, which are popular in apartment complexes, are powered directly from the motor's large frame. Okay, next slide. Okay, 2.21, the lift or elevator. Hydraulic elevators are used in the building with 5 to 6 floors. Each minute, this elevator can travel a distance of 61 minutes straight to 100 feet. A piston with a cylinder provides the power of hydraulic elevator. There are there are four varieties of hydraulic elevators: holeless, rope, and uh, cables. Okay, those who okay, next slide. Okay. Up to 50%. Up to 50% more capacity may be achieved with a constant of speed of 5 milli per second and arrival every 15 to 30 seconds, while allowing for substantial space savings since the compartment will be smaller. The maglev is an abbreviation for electromagnetic levitation technology. This use magnetic power to make ultra high-speed trains glide effortlessly over a track. For the vertical plane, uh, ThyssenKrupp is working on a multi-system and elevator system without rope. The next slide. The 2.22, the 2.2.2, the twin system for skyscrapers and other tall buildings. ThyssenKrupp has developed a twin system. It will decrease the number of shafts needed by a third to making it more space efficient than a conventional elevator. The elimination of two elevator shafts and the reduction of the size of the lobby on each floor of a building may save the equivalent of more than 20 hotel rooms. The routine system decreases shaft construction materials and thereby frees up valuable space. Okay? One machine controls two elevators in the same shaft, saving even more space and power. The automated system optimizes the journey of both cabins by allocating the most efficient location for passengers. As a result, there is an extra reduction in consumption. Next slide. The 2.3 is local document. The lifts and escalator are important pieces of equipment that passengers use every day, but they also have to be taken care of in order to function properly. If preventive maintenance is not done correctly, the failures will occur, resulting in high cost and more downtime. It is possible that vandalism or misuse of elevator and escalator may impair their functionality. Among these regulations are a set of requirements that must be observed. Part 1 is the general. This is for part 2, the design, construction, installation, and test. Part 3 maintenance. For regulation 31, duties of the owner. And for part 4 is miscellaneous. Next slide. Plus, this is 2.4 international document. The elevators must be installed in all non-residential buildings with more than 4 floors above or below the principal entrance level. There should be at least 1,800 millimeter of room in front of the door of every elevator in a vertical access system for handicapped individuals. The location and orientation of the elevator vehicle should be clearly displayed, in each elevator lobby, while the direction of travel and flow of the elevator car should be clearly shown by an indicator in the elevator car. According to UBBL 1984, according to UBL clause 153, the elevator lobby must include a smoke detector and be large enough to handle both lines of traffic. Coach, Mr. Isaac.
Okay, thank you, Mr. Zafri. Now we'll explain about the design approach. Okay, 3.1, design of the lift system in new and existing building. To design a new lift system, a few steps that need to be taken are brief review of the project, review of legal requirements and standards, determination of lift specification based on lift traffic analysis. For replacement of lift in existing building, site inspection must be carried out to determine the suitability, adequacy of space, and the location of installation of lift. Needs existing structure and electricity supply. Next, 3.1.1, brief review of the project. Types of lift required by customers such as passenger lift, goods lift, patient lift, and person with disability (PWD) lift. Number of lift required. Next, ceiling of allotment provided by customer. Special need by customers such as packaging type and additional accessories such as closed circuit television or CCTV and LCD system monitor. Lastly, are the requirement to be taken into account for the operation of the efficient lift system in line with the needs of customers, such as the layout of the lift, function and usage. Next. Review of legal requirement and standards are the design of the lift system should be carried out with reference, but not limited to legislations, acts, regulations, standards, letter of instruction or circulars and guidelines. Lastly, determination of lift specification based on lift traffic analysis. Lift traffic analysis is a method of determining the handling capacity of an elevator system installed in a building. The lift design mostly uses the up-peak round-trip approach, a lift system that provides services to feed residents in a building whose initial origin is empty. The lift traffic analysis will be the basis for determining important parameters lift systems such as speed, capacity, number, and so on. Next. Alright, what is lift traffic analysis? Firstly, we must calculate the round trip time or RTT. Up-peak lift design calculation theory for lift traffic analysis. Start with assumption there is a passenger A. Arrive at the very bottom using the lift service that stop at some level and stop to the highest desired level, and eventually return to the highest level down without stopping. The time taken during the lift journey is called RTT, which is it will be calculated in seconds. Generally speaking, RTT will provide an face of another passenger, which is B, who waiting for the lift to be boarded by passenger A. Next. Alright. The next thing is up-peak interval or UPPINT. If the lift use exceed 1 unit, the waiting time is named UPPINT. It is an RTT value divided by the number of elevators, or L. So the below that is the formula for up-peak interval. Next. Okay. The third thing is up-peak handling capacity or UPPHC. UPPHC is the number of passenger that can be carried from the main terminal on the ground floor to the top floor of the building within 5 minutes of peak activity. It explains the capability of the lift operating the passenger within 5 minutes. Next. Percentage of building population. Percentage of building population or percent pop states the percentage of the population in which they are accommodated by the lift system. So the higher the percentage of the population, the better such lift services. Alright, next. Okay, lastly, this is the lift traffic analysis flowchart. Firstly, as you can see, we need to identify building type. For example, like quarters, offices, hospital, and others. So next step is list initial parameter for analysis round trip time or RTT. For example, type of building, number of service level, distance from floor to floor, gross floor area or GFA, total distance travel elevators, and others. Next, we need to make the RTT calculation. After that, UPPINT calculation. Then, we need to identify the value of UPPINT is certified of or not. If yes, we proceed with analysis result RTT, speed, bill of lift, and capacity of lift. And lastly, set such specification of the lift. If the value of UPPINT is not satisfied, we need add the number of the lift, and then we must make the UPPINT calculation. If the number of lift is not satisfied, we need to add the speed or capacity of the lift, and then if the value is satisfied, we need to list back the initial parameter for analysis round trip time or RTT. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, I will reason about the result and discussions. So the first one, we must set the parameter of the building. Type of the building is hotel and floor, 13 floors. Floor service, which that use lift, only 12 floors. Rooms, the guest room, 89 rooms. Floor to floor distance, 3.35 meters. GFA 2923.44 meter square. This distance is 3.35 meter times 12. Okay. For the first one is total population. POP, and handling capacity. So, as I mentioned above, this building type is hotel. So, we use hotel occupancy based on CIBSE 2020, that is 2.0 guests per room that we use in this project. Number of the room is 89 rooms, 89 times 2.0 guests per room and equal to 178 guests, which is person. That is our total population for this hotel. The next one is for handling capacity based on the table from CIBSE. The hotel passenger arrival rate, uh, Hotel Api is 12% for 12% for 5 minutes passenger arrival. Hotel handling capacity taken are 12% of total population, 178%. So this formula can be seen below, and the value that we get is 21.36%, that conclude become 22% in 5 minutes duration, that this lift must be capable to handle. So, and then the next one is parameter to be analyzed, RTT. Okay, and this is the formula, and then P is number of people to be operated within 5 minutes with the lift, with the number of the lift. H is maximum travel probability of an elevator. S is probability of lift stopping in one trip. TV is time taken for lift to move up. T time taken for one unit lift to move to one floor, and TP is average time passenger in and out from the lift. And then for the service quality, again based on CIBSE, the the typical nominal travel time that we choose in this project is hotel, and then hotel is the standard type. Therefore, the total trip for one lift for 5 minutes is, as can be seen, the calculation, we get 10 trips, 10 trips for 5 minutes. All right, and then number two, value of person, P. Lift system needs to complete 10 trips in 5 minutes. Thus, 22% need to be divided into 10 trips of lift that can be conclude 3% in a lift for one trip. To accommodate for luggage, the area per person in a hotel may need to be expanded based on a 75 kilometer individual. A proposed value is 0.2 meter square per person based on CIBSE. So as you can see, this formula 75 kilograms times by 3% in the lift, then we get 225 kilogram. And then the minimum rate load listed for lift is 450 kilo. So we get we take the value. So the P value taken is 5.5%, which conclude become 6%. Okay. Number three, H and S value. Based on the number of floor, the number floor is 12 that serve the elevator. So H and S value we can get here 10.7 seconds, and S is 4.9. So number four, adjacent floor transit time, TV. The formula is TV equals to a floor distance divided by speed. Floor distance is 3.35 meter. So the recommended maximum travel distance for various rate speed is 1.6. So the amount that we choose is 1.6 rate speed. And then travel time for various building types is it is small hotel for our project. So the travel time second is 30 seconds. So TV equals to 3.35 meter divided by 1.6 meter per square meter TV equal to 3.35 meter divided by 1.6 meter per second. So TV is 2.09 seconds. Number five is value of performance time. As we can see, this is the formula. After we have calculated, the T amount is 9.2 seconds. Based on this table, single floor flight times. Based on the speed we choose, rate speed 1.6 meter per second. The single floor flight time is 4.2 TF. That is TF. And then door times for this project is 8. The next one is door time. Door time seconds for state door with millimeter. The door measurement is 800. So for closing time and opening time. So it is choose 2.0 second and 2.0 second for the opening and closing. Then the value we put in the formula, and then we get all the value for T. Okay. For number 6, value of TP, average passenger transfer time. For this project, the rate load is 480 kilos. The minimum based on the table that I've mentioned above. So the typical door width is 800. So TP is 1.2 seconds. Okay. After number 1 and until number 6 have been count, we can put in the formula RTT. So the amount we get is 99.88 seconds. So for the up pin, the formula RTT divided by number of leaves, that is L. So we can get 49.9 seconds. Therefore, the unit leaf with maximum capacity of 6% every trip achieve the requirement for quality of service with interval 30 seconds. And then uppeak handling capacity, UPHC. UPHC, the amount that we get is 58%. 58% for this lift. Uppeak handling capacity. So and then quality checking of service using percentage of POP. POP. Okay. So this is the formula: percent POP UPPHC times 100 and divided by U. U is the population flow service. Population flow service we can get here 164%. Okay, based on the formula. And then percent POP we get 35.4%. Therefore, 35.4% of rebuilding population for 2 units of lift service prepared to all floor in 5-minute duration. Okay. For the next one is discussion. The lift traffic analysis calculation is used in these features to assess of lift construction. The calculation parameter used are type of building, number of floor, and floor service, number of room, distance, floor to floor, GFA, lift distance, and POP and HC. Usually the traffic at the hotel are heavier than the traffic at the residential apartment because the morning and afternoon check-in charge are higher. Residential structure have two-way traffic. However, there is more down travel in the morning and more incoming traffic in the evening. Therefore, the type of hotel is specifically for holiday. With the chosen speed is 1.6 meter per second. The chosen lift type are acceptable. And then the percent for POP is 35.4% of the building population for 2 units of lift service prepared to all floor in 5-minute duration of time. The quality of service between 35 to 40 seconds can be considered as fair, and it is acceptable by CIBSE.
For conclusion, Elevators allow young children, patients, and everyone else to move from one floor to another. We would not have tall buildings or stunning structures like the Burj Khalifa if elevators did not exist. The elevator is used by over 90% of the population. Elevators are necessary for patients, visitors, guests, guardians, young children, and other visitors. It makes our life easier by allowing us to work and move between floors more quickly, transporting items with ease, and keeping us comfortable and relaxed throughout the voyage. Thank you.